look at isosceles right triangles, if you didn't write this down, write this at the top of your paper. One way to write isosceles right triangles is to draw a right triangle and to make the sides equal. That's what these little marks mean. If these two sides are equal, we're looking at an isosceles right triangle. One way to look at it is that these angles are 45 and 45 because they have to be complements, because they have to add up to 90 to make 180. And that means these are 45 even though we don't write it. Same thing down here. I could say that just the angles are equal, but that means that the opposite sides are equal as well. Another way of writing the same thing is to put a 90 and a 45. Can you all see this other one has to be 45? Because if this one is 45, then this one has to be 45. And if these are equal, then the sides are equal. So it's a way of seeing an isosceles right triangle. The last one is if you have a square and you cut the diagonal of that square, you're going to end up with two equal sides and a right triangle. So that's going to give you two isosceles right triangles. Now we're going to start with the easiest possible type, and that is if I know this side is 11 units, I should be able to write down the other two sides based on the pattern. You don't have to figure out that this is 45 degrees and look up the tangent and work out the trig. You just have to know the pattern. And if you look at these two, you can see they're equal. That's what this means. And then there's a pattern for this side. Anastasia, what's this side right here? No, what's this side? If this one's 11, what's this side? 11. And Garion, what's this side over here? The hypotenuse. Your 11 root 2. Yeah, if you look it up, if you look up isosceles right triangles, we can see that they have a pattern, A, and A root 2. So these two are the same, and this one gets multiplied by the square root of 2. Now, we read it like this, 11 square root of 2, or we say 11 root 2. We don't usually say 11 times square root of 2, but that's what that means. The square root of 2 is just a number. It's approximately 1.414, and then there's some more decimals. In fact, this is called an irrational number, and these decimals go on forever and ever and ever. This decimal never ends, never repeats. It'll repeat itself maybe a million times, but it will eventually stop repeating and it'll just keep going forever. This was so weird that the guy who came up with this idea of irrational numbers, the Pythagoreans drowned him. He was a member and he came to the Pythagoreans and he said, you know, guys, there are such a thing as irrational numbers, and they killed him to kind of keep the secret. This number, if I multiply it by 11, I'm going to get about 15.4, more or less, 15.54. But this is an exact answer. This isn't approximate or close. It is the exact answer. And they used A, and A root 2 to describe that relationship in your worksheet. So the other possibility is that maybe I could put something like 17 square root of 2 on here and ask for the two legs. So what are the two legs, Freddie? The equal legs. Okay, so this one is 11 root 2, and these are both 11, aren't they? This one is 17 root 2, so what are these two? These are 17. This is the case. This little arc right here means that these two angles are equal, which means it's an isosceles right triangle. It also means that they're 45 degrees and that the sides are equal. All that's true just based on the equal angles. Now, you ready for the hard one? There is a hard example. This one is pretty straightforward. If I know the side or the leg, I can find the hypotenuse by multiplying by root 2. If I know that the hypotenuse is 17 root 2, I can divide by the square root of 2 and get the leg. Now, one thing we do know is that all triangles like these, all these isosceles right triangles, have a square root of 2 on at least one of the legs, always. Now, what if it's missing from here? What if this is 18? What if this doesn't have a square root of 2? Then I know for sure that these have a square root of 2 on them. And the trick for this is really easy. I've got two equal sides, and I'm just going to divide it equally. 9 root 2 and 9 root 2. It is that easy. If I know the hypotenuse, I can divide it into two equal parts. The same thing is true if I know the sides are like n root 2 and n root 2. Then I know that the hypotenuse is 2n. I can either double these guys and get the hypotenuse without the square root of 2, or I can take off and divide it into two equal parts with the square root of 2 on it. This is just a pattern. To help you see it a little better, remember I multiply by square root of 2 to get here? You guys remember that? 9 root 2 times root 2 gives me this one. Look what happens. When I take this times the square root of 2, you see these two? They cancel each other out. This is the same as 9 times the square root of 4, but this is just 2. 9 times 2 is 18, and we can see that it does work. So the last example, I'll leave it for you for a second. I know this side, for example, this diagonal. If this diagonal was exactly 32 inches, figure out what the two sides have to be. It's just like this example. This is missing its radical 2, so I think of it like 2n. And then this is going to be n root 2 and n root 2. What is it right here? But what is it? What's the number? This one is 32, so we split it up into two equal parts. 16 root 2 and 16 root 2. That's right, Brian. Okay? That's the first kind of special right triangle. Now there is another kind that we have to do today. And that is your 30, 60, 90. Hopefully you drew through your triangles. You can see that I really messed this one up. But like I said, it doesn't matter. They don't have to be perfectly drawn. You just have to draw them more or less. And we're going to do the 30, 60, 90 right triangle. Now these guys have two equal sides and they have a square root of 2 in them. This one has 3 equal sides because when you get one of these, You're literally cutting an equilateral triangle into two equal pieces. For equilateral triangles, it's 60 and 60. And when I cut it into two equal pieces, I get 30 and 30, and this is 90. Notice there's a lot of threes involved in this. There's 30, 60, 90, which are all multiples of 3. I've got 3 equal sides for the equilateral triangle. And this one, we're going to start with a real easy example. We're going to start with this side is 7. We call this side the short leg. Then we're going to find the other 2 parts. This is the easy example. And the way I think about it, think about the fact that this is an equilateral triangle, and this piece right here is 7. It's exactly half of the whole side. See, the sides have to be all equal, and that this is cut in half. So this has been cut in half, and this is 7. That means that this side has to be doubled to get it. So this one is 14. The hypotenuse is 14. On your worksheet, they listed it like this. They said if the short leg is A, then the hypotenuse is 2A. So if this side is A, this one is 2A. And they said that this one, the long leg, is A root 3. So I have to multiply this times the square root of 3 to get my long leg. And it's going to be 7 root 3. The way they wrote it in your worksheet is A root 3. Sometimes they'll put N or X or something else. All right, ready for another easy one? Now the other easy type is when you know what this side is. Let's say I know that this side is 16. Now I can find the other 2. Find your other 2 sides. The hypotenuse is going to be 16, and remember it represents 2A. One way to look at it. And then you need to find the other 2 sides. So do that. Alicia, what's the short leg for this one? Well, this is 16. How big is it? This is 8. We just divide by 2. And it is represented by A, if you like. What is it? Yeah. Yeah. All right. And if I know short leg, I can multiply it by root 3. Again, this is just a number. It's approximately 1.732. And it goes on forever and ever and ever, but it's approximately this number. And this, of course, is going to be 8 root 3, because I'm just going to multiply it by 8, the short leg, times root 3, and it's A root 3, just like in your worksheet. Now for the hard part. And it's really not that bad, because there's a weird pattern that I want to show you. And it's going to work sort of like this one did. You see how this one had the n root 2 and the n root 2, and then this side was 2n? That it's missing its square root of 2? Now, normally, this long leg has the root 3 in it. But on this one, the example I'm going to show you, we're going to be missing the root 3. So I'm going to say this side is 21. Oh, you know what? Let's go with 24. Now, this side is missing its square root of 3. See what I mean? And so what I need to do is divide it into 3 equal parts and get a root 3 on it. What's 24 divided by 3? 8. Yeah. If this is 3n, then this side is 8 root 3, which is n root 3. I'm going to split it up into 3 equal parts. The other 2 parts are over here. 8 root 3 times 2 is 16 root 3. Kind of like what I did on the other one. If I've got a side that's missing its square root of 3, I divide it into 3 equal parts. One of them goes here, 2 of them go here. This is 2n root 3. And this side is 3n. Probably used a bad number example. I'll pick a better one for this for the last one. Yes. Right here or here? This says n root 3. If this is 3n, if this side is 3 times n, then this side is n times the square root of 3. We divide it by 3 parts. Let me give you a better example. Guys, look up here for just a second. If this side is 15, then I divide it into 3 equal parts, and this one gets the 5 root 3, and we know we have to double it for the hypotenuse, so this one gets the 10 root 3. It might be easier to see that the 15 splits up into 3 equal parts. 1 goes here and 2 go here. If this one was 45, this one would be 15 and this one would be 30. I split it up into 1 part and 2 parts here. If this one's 3, this one is 1, and this one is 2. Last one. This is a tent. This represents the front of the tent. And each one of these sides is going to be 10 feet. And they might ask you, what is the height of the pole that holds the tent up? So this is going to be the long leg is going to be the pole. If this is 60 and 60, this is an equilateral triangle. I know the hypotenuse. I need to use it to find the short leg. And when I know the short leg, I can find the hypotenuse. Or, sorry, the long leg. If the hypotenuse is 10, what's the short leg, guys? This one is 5. And the long leg, just have to multiply by root 3. So it's going to be exactly 5 root 3. If we're talking about a tent, it's not going to have any specifics like that. But if you're doing nuclear physics, you kind of want to be specific and have really good, be very, very accurate. This is an exact answer right here. This looks just like the questions on your quiz today from Canvas. It's got 6 questions. I took it myself and I took my time. It took me 42 seconds to answer all 6 questions. No, it's because if you look at a question like this, it doesn't take any time. It just takes, do you know the pattern? Yeah. That's why you should probably take about 4 or 5 minutes, not 42 seconds. Anyway. Sorry?